she didn't get it right the first time.
Imagine that.
So we're in compound interest. Simple interest, we're just adding the same amount every year. Compound interest, we're getting interest on the interest. And that's the way your student loans are funded, by compound interest. Our retirement accounts, the money you put in the retirement account between age 20 and 30 will be worth more than all the money you put in past 30 due to compound interest. If you're going to put $100 a month into a retirement account, the money you put in the first 10 years of that retirement account will be worth more at retirement than the rest of it combined, which is good and bad. So Uncle Nick deposits $5,000 and at 6% interest, and when you're born and at age 18, it's going to be worth something else. And maybe it'll tell us how. Okay, there we go. And so the first birthday, it's worth 1,300. Looks like 5,300. And then the second birthday, that the interest amount squared, and then it's squared again and cubed into the fourth and to the fifth. So you end up getting 1.6 to the 18th power times 5,000 is going to be the money that's going to be there after his 18th birthday. And the 5,000 wasn't very much, but the 14,000 might be okay. Now, the issue is 18 years later, is that worth half that? Is that worth as much as the 5,000? So you could have had some interest, some depreciation going on because of inflation. So that may not be enough to pay one semester's tuition 18 years from now. And on the 19th year, we'd raise it to the 19th power, and we would get more. And 60 years in, so on his 60th birthday, $164,000 is sitting in the bank. But chances are you've gone and if it was in an account where you had to pay taxes on it, you had to remove taxes from that every year. And if it was in an account that you could get to easily, you probably did and spent it all, right? Yeah. But if some distant relative invested for you and didn't tell you about it until they died, and then the attorney called you up, then that might be a different issue. And now we can see that money growing, and we can see that the ever so slightly the slope of this curve is getting bigger. See that it gets bigger there than it is down here. Maybe you can see that. But the 18th year was here. Now the slope gets even larger as you're getting out to the 60th year, as that compound interest is growing quicker. So that's the formula we're using. The future value of the dollars is some principal of the dollars times whatever the rate of return is in percentage. 1 plus the rate of return to some number t in years. And that's the formula we're using. Now, on your calculator, you have a key that raises to some power key, right? So, on my calculator, that's helpful. Yeah, that's good. So right there is my raise to the power key. So I could have 1.05.
It's not on.
Oh, good point. .05 raised to the 80th power. There's the other key. There it is. Boom. So I would go up, if I had it in the bank for 80 years, I'd go up 49 times whatever the principal was. So if somebody wants you to go on some multi-generational trip to another planet and back, and so put money in the bank. When your great-great-great-grandson gets back here, it'll be worth a lot of money, unless the lawyer went and stole it all on you, which is entirely possible too. Anyway, so that's the formula we're going to use, and probably when we go, we'll start writing them on the board, so it's time to use it. I'm going to turn it on and find it. Otherwise, it's going to be fumbling in the book looking for it. Imagine you have $875 in savings, and you want to have $2,000 saved in 7.5 years. At what percentage rate are you going to have to do that? Well, you'd use the same formula again, except this time you'd solve for rate. Maybe I can remember that. Well, it says 7.5 years. So I have 875, and I want 2,000, and I'm going to multiply 1 times rate times, is it 6.5 years?
7.5.
7.5 years. So I'd go 2,000 divided by 875, 1 plus R, 6.5. Then I would take
7.5.
Again? 7.5. Then I take the log of both sides. And it doesn't matter if I take the natural log or the common log as long as I take the same log. And because the log of x to the 5th is the same as 5 log x, I can bring the 7.5 out in front and have log 2200 divided by 875 is equal to 7.5 log 1 plus R. So then I go and put in my calculator 2,000 divided by 875, and then I'd figure out where my log button was. There it is. So log of the answer, so I have 0.359, 7.5 log 1 plus R. I divide by 7.5 log 1 plus R, and then I'd raise both of these to powers of 10. So I'd have 0.3959, 0.359 divided by 7.5, and then I'd go power of 10, power of 10 raised the answer, .1165 is equal to log 1 plus R. And the log goes away because 10 raised to the power of log would be the log would go away. Bring the 1 to the other side. So my rate's going to have to be 11.65% if I want that $875 to be worth $2,000 in 7.5 years. So that's how I would work a problem like that. If that isn't bore you silly, I don't know what else would. But all right. So and they're doing it for 7 years. We did it for 7.5. But they're showing that we fall short. So if we only get 6.75% interest for 7 years, we're going to fall short of our goal. And or we'd have to put that much money in either way. So we'd have to put more than $750 if we want to get to our goal in time. 7.5 years, blah, 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 far short of the goal. All right, now we're going to do the computation. We'll have to use a variation. We're going to get some different type of interest. Okay, so now we're doing monthly interest, and for 7.5 years, that's going to be 90 months. So we took the interest rate, divided it by 12, and then went for 90 months. And even if we compound interest monthly, we're still going to fall short. The goal is something else. So now we're going to go in and get another compounding daily. So we're going to divide by 365 days to see what the interest rate is. And we can't really divide by 365. We have to divide by 365 and a quarter, right? Because if you're going to do it over a long period of time, there's an extra day thrown in, leap year every 4 years. And if I do that, I end up with 14,051. That's not a whole heck of a lot more. And so that didn't do much difference either. So if I compound annually, monthly, or daily, that really isn't a whole lot of money difference when I do something like that. And I can I can do it every nanosecond if I wanted to, but that wouldn't make much difference either. This is the formula we're using. So if I'm doing something at some rate other than years, so I'm doing 4 times a year, or 5 times a year, or something like that, R divided by N and T. So T is still in years. N would be the number of times I'm doing it per year. And that would be the general formula I would use. And they go and they write a simpler formula. Well, with the simpler formula, you can't solve anything without knowing what it is, so that's really silly. Now we can have continuous compounding, and when we do continuous compounding, we end up throwing in E, the base of the natural logarithms. That means we have to move back, right, and discuss E. Did I tell you that pi is 3.141592, is it 56?
I only have the 3.14. That's all we ever had to know.
3.1465. All right, now how would I know that? Well, because Columbus sailed the ocean blue in 1695, and because Magellan circumnavigated the globe in 1565. Now he really didn't. He only made it to the Philippines, but his boat made it with the crew. It's just that he died off in the Philippines. Now pi is E, the base of the natural logarithms, is 2.71828. All right, so the issue is, what's so important about 1828 that it appears there twice? Now clearly the ancient Greeks had no clue that Columbus was going to sail the ocean blue, or that Magellan was going to circumnavigate the earth. In fact, it wasn't until 600 AD that pi was expressed as a decimal number. Before that, it was expressed as something other than that. So that representation of pi was not known to the ancient Greeks. Neither the ancient Greeks knew about the E, but they didn't have it to that many decimal points naturally. Nor did they have a decimal system to put it in that many decimal points. Anyway, back to the issue at hand. In 1828, the first public high school was started in New York City, if I can spell New York City, and in Boston. So prior to that time, there were high schools, but they were all private high schools, and you had to pay to go there. But in 1828 we had our first public high school. Well, that definitely was important to this lesson. So, but if I have a continuous rate of interest, then that's the formula I'm going to use. So 7.5 years times so much raised to the E will give me some continuous rate. Now, if you remember that this was $1,451 and some cents when I did it daily, yeah, so doing it continuously does not improve how much money I get back as much as I could. 21-cent difference between daily and continuously. We have an annual percentage yield. Okay, so we start with 1,000. We got 1,099.60. That means we had 99.60. It would be our percentage annual yield. I take that number, multiply it times that, gives me that number back. And so there's an interest rate, and then there's an effective interest rate because it's being compounded, which is going to be slightly more. So I have some money, I made some difference divided by what I started with. That's going to give me my annual percentage for the year. Energy, percentage yield, blah, blah, blah. Comparing investments through that, so I could have 6.7% or 6.75 or 6.8%. That's good. And nothing new there. So if I have 12 years, I'm compounded monthly. Okay, so I'm compounded monthly. My interest rate is 6.75, but my yield is 6.963. So I advertise one interest rate and charge you another one. Isn't that good? Yeah. So I'm going to charge you 6.75 interest, but the annual percentage yield is going to be 6.93 because the interest is compounded. All right. Future value of the dollar. So I have 6.8% interest. I'm compounded quarterly. I get $1.06, 9 point whatever. That's going to get rounded off or truncated and thrown in the president's bag, one or the other. But I end up with a effective yield that's higher than my what I said I was going to charge you. So what's our best choice? Not to borrow money would be our best choice. And the difference between how I compound it would not be that much different. Okay, looking at homework problems. Did we do 11 last time?
Yeah, we did up to 29 last time.
We did up to 29 last time, really?
Mm-hmm.
Wow. Okay. I don't have it marked. So 31. It's the next one we have to do. Suppose you deposit some money in the savings account, 9% annual interest, with interest accredited to the account at the end of each year. Assume that no withdrawals are made. Find the balance 4 years and 5 years, 7 months. Okay, so I'm going to take 3250 times 1 plus the interest rate, 0.09. And it's their balance after 4 years. Okay, so raise to the 4th power. 1.09 raised to the 4th power. Times 3250. 4587.64. And it doesn't say to the nearest penny or something. No, it doesn't. All right. 5 years, 7 months. Well, 5 years, 7 months, it's not going to give you any interest until the end of the year, so that's the same as 5 years. So that's not going to be a 5 raised to the 5 point whatever. It's just raised to the 5. $5,053. Okay, page 49, number 49. The sum of money is invested in a CD. At the end of a 3-year, you get a check for that. How much money was originally deposited? Okay, so I have 4060.17. That's going to equal some amount of money, don't know what it is, times 1 plus the interest rate, 0.475 raised to the end of 3 years. 3 years. Okay, so the amount I had originally, and we'll change that back from an X to a P for principal. That would seem like a good thing to do, P. So my principal is going to be 4060.7 divided by 1.0475 raised to the third. That's a 17.
I don't think that 0 needs to be there. Oh wait, yeah, it does. Never mind. All right.
Excellent. You did an excellent job. You distracted me, hit the wrong number. Going to be here all day because I can't do the problem. No, I can push buttons quicker than that. Maybe. It looks like I started with 3532.50. So I started. Okay. On to the next section. That was 3. This is 4. Geometric sequences. Isn't that lovely? So a geometric sequence, you start with some number p, and from there on you multiply it by something to get the next number, and that's called the common ratio. So I could have 5, and I could be multiplying by 2, so I could have 5, 10, 20, 40, 60. If c is bigger than 1, I get bigger. If c is less than 1, I get smaller. So I could be multiplying by a third. I could have 27, 9, 3, 1, 1/3, 1/9, out to something. I could have a negative number. I could be multiplying by minus 1/3. So I could have a minus 9th plus 3, minus 1 plus a third minus 9th, etc. Okay, so my geometric sequence would be whatever it is, whatever the common ratio is, p, the common ratio squared, p, etc., etc. Isn't that lovely? And we could call G0, the first guy in our geometric series is p, G1, c to the p, G2, c squared, blah, blah, blah. And Gn, the nth term, is going to be c times the n minus 1 term. And the n term is going to be c to the nth power times the first term. Isn't that lovely? So I got 1,000, and I have a common ratio of 1.06. So that's sort of like I have 6% interest on my loan, and G1 gives me $5,300 in the bank, and G2, the second year, gives me 5618, and G3 gives me 5955. So this geometric series is being used in money to show how much money I'm getting in the bank every year with the interest I'm getting. If we put a dollar sign in front of these things, then it all becomes dollars, and we end up with how much money I have on my 9th birthday. And I think I skipped one. All right. So if C is 0.3, that means we have a 70% decrease every single time. So I could have a population of 1 million, and I could drop by 0.3. I have 300,000 reported cases, and then 90 reported cases, and so on. And what is this, some flu or something? So we have some, by the year 2014, we have a virus that's spreading, and the virus is going to wipe itself out because everybody's going to be immune to it pretty soon. So now we're going to have useful formulas. Oh, yes. So if I'm adding the geometric sum together, and I keep on going forever and ever, then that's going to be P C minus 1, C to the n minus 1 divided by C minus 1. So the summation of the geometric series ends up being whatever the first term is, whatever the common ratio is, divided by C minus 1. So I can go out to the nth term that way. And the summation going out to the nth term. So I'm not going to infinity, I'm just going. So that'd be the first term, second, third, fourth. What in the world is that? Oh, it's the guy in the middle. All right. At the emergent stage of spread of HIV, or the West Nile virus. So we have case 0 in the year 2000. We have 0 in that year, and then we have 5,000 cases coming up. And we have some growth rate, annual growth rate, as this thing spreads. And we're all going to be dead by 2017. Anybody dead yet? No, you're all alive? I doubt it. All right, could be. So we have 5,000 cases, and then we have 7,000 and 9,800 and 103. Anyway, it could be scary if you look at your computer and see some disease spreading across the thing. But as long as we don't all turn into zombies, it should be okay, right? And then the sum of the first 10 guys, 3,035, whatever that number is, huge number. And we go out to the 15th guy, huge number. But by then we got a vaccine, and we're not going to do much. 2 trillion cases of virus X. Well, we'd just all wash our hands and it wouldn't be a problem, right? Yeah. So quit hugging. We just quit hugging, no shaking hands, wash our hands often. Well, that wasn't too painful, I don't think. It might have been, I don't know. Because then there's the next, oh, we got to do homework problems, right? Okay. So we did 41. So 50, so we did 51. Find G1. Okay, so G0 is 11. G1 is going to be 1.25 times 11. Oh, I think I can do that. No, I can't. 1.25 times 11. 13.75. And then we want G6. Oh, that's G6. 1.25 raised to the sixth times 11. Oh, way to go. $41.96. 41.96. And then we want GN. 1.25 raised to the n times 11. Is that all there is, right? No more? Yep, that's all there is. 5161. All right. Use the geometric formula to compute the following. Okay, so C is equal to 1 over 1.05. And the geometric sum says we take what we start with, which is 10, and we multiply it by 1 over 1.05 times, we're going out to 6. We're going, question, yes.
Yeah, sorry. The GN, how do you find N?
You don't.
Is it just 1.25?
No.
It's nothing?
No, we don't know what N is.
Oh.
Yeah, that's the whole point.
Okay.
Yeah, we don't know. It's a general formula for the nth term, whatever it is. So if N is 100, then I put 100 up there, and if N is 150, I put 150 up there.
Okay.
Yeah.
Sorry.
That's perfectly okay. Where was I? Raised to the n. Why do I think that's the wrong formula? I don't know. I'm just that way. Nope, that's right. But it's n minus 1 is the last term. I had 36 there, so I need 37 there. Minus 1 divided by 1 over 1.05 minus 1. Okay, so that's the formula I'm doing. 1 divided by 1.05 raised to the 37 minus 1 equals divided by parentheses 1 divided by 1.05 minus 1 close parentheses times 10. Oh, that can't be the case. I've got 175. Okay, so that'd be, yeah, I guess so. 175. Yeah, that's probably right. We could look in the back of the book, but we're not going to bother. All right, only 2 more problems to work before we pass out the quiz. That be interesting. Okay, we don't want to do that, so get out of there. Come back to here. Section 5. I think we're doing section 5. Deferred annuities, planned savings for the future. So here's a case where we're going to put money away so that sometimes in the future we're going to get some money back. Or we're going to die off and somebody else is going to get the money. So fixed annuities, a sequence of equal payments made over regular periods of time, often distinguished under names. Today's financial world gives us a lot of those. So You could be making a regular deposit to save up for a vacation or something, and then at some time in the future, you would be done. You could have an installment loan where you're buying a car. You could win the jackpot in the lottery and decide that you want to cash fund some, or you could decide I'd want annual payments, and they would annuitize it for you. It's a form of payments. First come the reward, and then comes paying it back. Setting up a college trust fund. Given the cost of college, you may want to put money in the bank for your children. Do you want to put money in the bank for your children's college? Why?
Not really. I had to pay for my
You
own.
can afford it.
So we need to talk about that for a moment. Here's money in the account for your college, for your daughter's or son's college fund. How much do you have in that account after the first year?
Less than what was in there before.
You have 2/3 because you spent 1/3 of it on their first year of college. How much do you have after the second year of college?
1/3.
2/3 of what you had before. So 2/3 of 2/3 would be 4/9. So you have 4/9, less than half. And then after the end of the next year, first year down to there, second year down to there, third year, you're going to have 2/3 of that gone, so that'd be 8/27, and then at the end of their senior year, you're only going to have 16/81s left. That means not very much.
Enough to cover books.
Now, let's say that you, when they're 17 years old, you saved up money, right? But at the 17-year part, when they're 17 years old, 1 year away from going to college, you took half of this and you threw it into the cash value of a life insurance policy. You just happen to do that. Okay, what happens to the other half? Well, it loses 2/3, and it loses 1/3, it loses 1/3, it loses 1/3, it loses 1/3. It's got some piddly amount left over. What happened to the cash value of the life insurance policy, the other half? It went up by 4% interest, and then it went up by another 4% interest, and then it went up by another 4% interest, and then it went up by another 4% interest or more.
Yeah,
And when
you
he
can
grew,
only get it if you die.
no, cash value you can take out. Okay, so here's daughter one. I was really happy. I had $10,000 in the bank for her. She went to Penn State, and at the end of 4 years, I had $0 in the bank, and she had student loans up to yin yang. All right, and then I've learned my lesson. So son one is 2 years behind. I take $500 out of the $10,000 that is sitting there that I had for him, and put it in the cash value of his life insurance policy. He's 34 years old right now. We still have it, plus the interest. The rest of that money went away. Now, the daughter three went to, daughter two, I guess. Third child, daughter two. Went to the Coast Guard Academy. Coast Guard Academy. Cost me $3,000 up front and a tax deduction. As soon as she got her green ID card, she was no longer mine. She belonged to the government. I couldn't claim her as a tax deduction. Whatever money we had for her, set aside from college, we used to buy her a car. And then, but then, when daughter four happened, we had figured it out. Daughter three, fourth kid. We figured out she's 5 years behind, and she had zero money in the account for her college. She went to University of Connecticut for 4 years. She got a $1,000 a year scholarship for playing a viola. And we basically ended up paying whatever we needed out of our income, but we'd hidden all our money at that point. So as soon as you do, the first time you do the FAFTA, you know what money you have, and you know that anything in the kid's name is going to go to zero at the end of 4 years. And then by the time you get to the last child, you realize that you should have zero in the kid's name and most of your assets in IRAs, 401ks, and things like that, not money that is counted, cash value of life insurance policies. But, and then, oh, she shows financial need now. Oh, yes. Oh, yes. Isn't that great? Yeah. Which we didn't. So that's the issue. Put the money in the, okay, if you're going to be independently wealthy, put the money in the kid's name, knowing it's going to go away, right? Or put the money someplace where the FAFTA doesn't see it. Your IRA, your 401k.
Coffee can in the backyard.
Yeah. Coffee can in the backyard, yes. My mother-in-law had a cousin that died. So here's the cousin's house. Cousin was 80 years old at the time. Had a live-in girlfriend who'd been there for 10 years. Live-in girlfriend. The house is probably worth $200,000. The house is worth $200,000 easily. And no children, no brothers or sisters still alive, no will. Okay, so in the state of Connecticut, the 27 first cousins all get a cut. 1/27th. All right. Well, that's not unusual, right? Big families, that happens. What happened in his life 80 years ago? If you lived for 80 years, that's 10 years ago or so. That meant you lived through the Depression, right? When banks were failing. Do you like banks?
No.
You hate banks. In your basement, you have a vault. There's a vault in the basement. $300,000 in cash in the vault. Live-in girlfriend, no clue, didn't know it was there. He never told her. So
Well, the cousins knew, huh?
none of the cousins knew
Nobody
either.
knew anything about it.
No one
How
knew.
would you get that much? So whoever moved into that house got it, found it.
The attorney the attorney that was assigned to settle the estate went to the house to do an inventory and found a safe in the basement. Had the safe opened, it had $300,000 in it. This guy had taken his Social Security money, all of his money that he's gotten for his entire life. They didn't use to buy food or something, put the cash in the safe. That's where it was. Now, it would have been worth millions if he would have invested it, right? But that's where it was.
You hear stories like that all the time, that like people move
Yeah.
into houses and find cans full of money or something.
Yeah, exactly.
I wish it happened to me, but
Yeah.
I could use a $20 bill right now.
Mm-hmm.
yeah.
When my wife's grandfather died, she got the coin collection. All right. Where's the coin collection stored? In the attic. Let's store it in the attic. We were putting a new roof on the house one day, and the roofer said, "Did you guys know you had money up there in the attic?" "Oh yeah, we know we have money up there in the attic." And ever
You
see
guys
a
were thinking the coin collection.
ever see a 2-cent piece? Yeah, we made 2-cent pieces. I got 27 of them, I think. And anyway, now that coin collection that used to sit in the attic, 3 safety deposit boxes in Bellevue, 10 by 10 by whatever, how deep they are, 18 inches deep, is holding the coin collection, Grandpa's coin collection. And it's not all of it. He had more too, but
I take it it's worth more money than you thought it, you expected it to be.
we have never let anybody look at it for that purpose.
You just don't want to know what it's worth.
I don't want to know. Yeah.
Oh,
That's
I
right
don't
there.
know.
Now, I know that there's pennies, right? And then there's the wheat pennies, right? And there's the Indian head pennies, and there's the eagle head pennies, right? I have all the eagle heads except the one that's the expensive one. Before that, there were large cents that were a little bit smaller than that, and they were a day's wage at the time. A penny was a day's wage. And right now, those things, if all you can do is just see the date on them barely, they're $17 a piece. The ones that are more in better condition than that, they're worth more. But any coin collector, any coin person coming in to evaluate the collection to buy it from you is going to lowball you so bad. There's no reason to do that. And once it's gone, it's gone. And once you get the cash, you can never see it again.
Don't you want it appraised though for like will purposes and like?
No, my children can worry about it.
Smart kids. My grandpa, he collected the coins, and he sold his coin collection because, I don't know, my grandma and grandpa, their theory is once they're dead, they don't want the kids to fight over their stuff.
Yeah.
So if they sell it and get it rid of now,
Mm-hmm.
then they don't have a problem after they die.
Mm-hmm.
I don't know how much he got for it, but
Yep.
he had a really big collection.
But
Wow.
this thing has every half dollar since 1900, every quarter since 1900, a third of the things between 1900 and the Civil War. But when it comes to the half pennies, there's only one of them. When it comes to the 3-cent pieces, there's only 2 of them. And none of them are uncirculated. But the 1908 SSVB or whatever it is on the back, never saw one in my life. And this collection has 2 of them. Now, if they're in good condition, they're worth lots of money. In the condition they're in, they're worth like $50, and just isn't worth it. So yeah, if I wanted to shaft the children, I'd get rid of it. So anyway, should we set up a college fund or not? My view is don't. All you're going to do is be disappointed when all the money goes away, because you think it's yours. It's in the kid's name, right? And it's going away. And the younger, anyway, I won't go into that. But it's much better to keep the money someplace where the FAFA can't get a hold of it. Now, the federal government would rather have you save money for the kids' college so that they don't have to pay for it, right? They don't have to come up with government grants. Anyway, imagine mother decides to set up a college fund. She's going to put $100 from her paycheck monthly for the next 18 years at 6% interest. What is the future value of the fund 18 years from now? Okay, so not only do I have 1,200 the first year, but I have 1,200 the next year plus the interest of the first one added together. So that's what we're going to do. And then compounded. So I've got 214 months that this is going to happen. Okay, so I'm finding the interest rate 0.005 because it's 6% over 12 months. I have 216 months of interest. So on the first installment, the first $100 is worth that, whatever that number is. And then the second installment's that, the third one's this, and so on and so forth until I get to the last installment, which is only worth a mere $100.50, which isn't very much. But this is a geometric, sum of a geometric series is what we're seeing there. So that's we take out the 150 and we multiply it times that geometric series, and we have a formula to find that sum. So that's where that formula is coming from that I have on the board. So the principal times our numbers. So I end up with 38,000 and change in the bank if Mom just puts $100 a month away out of her paycheck. Now, that doesn't pay a year for at Penn State. That pays for both years at Iowa Western, but I don't think you can live in the dorm for that, can you? At Iowa Western, I don't think so too. So that may not have been enough. May have put $200, and then 18 years from now, how much is the college going to cost? It went up in cost too, right? So, but I can do that. So now I've got some number future value of the last payment. So what is the future value of the last payment? And then I got some principal divided by whatever, and that's what I'm going to do to figure out my annual fixed annuity. If the goal is to get to 50,000, then how much money do I have to put away a month? So I do it again, and I come up with, if I put down $129.08 a month, then I can have $50,000 in the bank for college for son or daughter at the 18th birthday. Okay. Now, families are families, right? Can children be disappointments?
Yes.
Can they be the most wonderful creatures that walk the earth?
Yes.
Only if you have a mirror and you're looking in it, right? So, my lovely last daughter, during her first week at the University of Connecticut, ended up having a gentleman fly into Connecticut who we forbade her to see as a 9th grader. He was a senior because it was bad news there. He stayed in the dorm for a whole week before her roommate's mother called up and complained, and daughter got a secret letter in her record that prevented her from being an RA for a whole year. And anyway, that call, and you know, my lovely wife thought that that'd be a good reason not to pay for college anymore. Well, probably it was, but we paid anyway. Now she's got a CPA and a master's degree in accounting and an MBA, and I guess we did the right thing, and the stupid boy isn't around, and I guess that makes that out. Okay, so anyway, we end up coming up with some amount that we'd have to put into the college fund. The main point of the example is that, boy, we're going to have to save a lot of money. Now, I was listening to some, now, if I'm a person who has your account, your retirement accounts, I'm getting a percentage out of them every year, right, for managing them. So I want you to put more money in. That's my goal. So when I come to your house to talk to you, I want more money from you. And your goal is to give me less money. Okay, so just one of those things. So what happens if we're going to save for a cruise? All right, we got 6.75%, we're investing 8.75, and we're saving for this cruise. How long will it take us to get to the amount that we want? What must we do? So we go and figure it out, and we come up with the principal for the amount that we have to come up with, and we need another $4.72 a month. Oh, what happened? We're done? Okay, we're done. All right. So deferred annuities. Looking at, let's see, we did 61 already, so we're going to do 63. Starting at age 25, Marcus. You know any Marcuses? Anybody? You do? Yeah, I have some Marcus stories to tell you sometime. Invested.
Marcus, is he from Buena Vista? Is he a student here?
No, he was a captain of mine on a submarine 30 years ago. So I don't think he's the same guy.
Oh.
Yeah.
Bummer.
This guy was about my height and 5 years older than I am. And no, probably not him, huh? Yeah.
Marcus, I know from here, makes me, well, and he doesn't go here anymore. But
Yeah.
makes me want to punch him in the face.
I guess it's, so this is a general thing about Marcuses. All of them are bad news. Anybody know any good Marcuses out there?
The one I know is ridiculous.
It is bad news too. Okay, so it must have to do with the name then. Well, anyway, we're going to invest $2,000 at the beginning of each year, and we're going to put it in our IRA at 7.52% compounded annually. And we want to know if he retires at age 65, his 40th and last deposit generates interest on for 1 year. What do we want to know? How much money will be in the retirement account? Okay. So we just saw the formula. Do we remember it? No. No. We don't. Alright, so now I gotta go back and find this stupid installment loan. Deferred payment, okay. So the last value, the value of the last deposit, 2,000 times 1.075. Okay, so we'll get that number first. $2,150. Okay, so we're going to take 2,150 times 1 plus the periodic interest 1.07, 0.075 raised to the time. 25th to 65 is 40 years. Raised to the 40th divided by 0.075, and we got a -1 on top. Okay, so that's the formula we want to do. 1.075 raised to the 40th, which is 18 point something, -1 equals, divided by 0.075 equals, times 2,150. Boom. $488,000. Almost $500,000. Now that would drive me to save money, right? Except I have money in an IRA, and the CDs are coming due, and they want to renew it at 1.95% interest. Isn't that lovely? Where does that get me?
Nowhere.
And I'm at 63 years old. So I told them, forget that. I'm withdrawing the money and taking it out. Yeah. I know. I mean, this is ridiculous. So back when Jimmy Carter was president and we're getting 18% interest, this is a really good deal. All of us were going to be millionaires before the end of his presidency. But ever since then, things have gone downhill.
They're raising minimum wage.
Yeah, that probably is helpful too.
Now that means everything else is just going to skyrocket.
73. Okay, so we have to do the last chapter before we can do 73, because the last chapter is about installment loans. And one more set of slides. Open. Oh, bummer. Talk fast. We're going to have to talk fast. Installment loans, cost of financing. So I buy a car, I get an installment loan, I pay it back. So I'm going to get a brand new red Mustang for $23,995. I really doubt it, which includes taxes and licensing fees. I doubt that. I have $5,000 that I've saved, and I'm going to throw it away on the Mustang, and I'm going to pay it off over 5 years. But luckily, my interest rate's only going to be 1.48%, and so there's the difference. So the issue is, how much am I going to have to pay? And I end up below, I'm up to 60, and I find if I add them all up, I get that. And I have some formula. Isn't that a great formula? I just love it. I love that formula. Financing of when we get the how much you have to pay on a mortgage, that would be the type of calculation we'd have to do. No one ever does that calculation. They look at a chart and they take it off of that. So we need $3,371 in those payments, and that's going to equal to a payment of whatever, and it's going to be more than what we can possibly want. And part 2. So now, should we choose the cash rebate, or should we choose zero financing? That's the issue. And so instead of having $18,900 to pay off, we have $16,900 to pay off at 0%, which is the better deal. So we do some calculations, and we come up with that the first way we're going to have a monthly payment of $33.2, and the second way we're going to have a payment of $31.16, and it looks like the 0% interest rate gave us a better deal until we look at, oh, I guess we don't see it. Oh well. Do we take the lump sum lottery option or not? Well, if I won the lottery right now and I was going to get paid off for over 30 years, am I going to be alive in 30 years?
No.
That probably wouldn't be a good idea for me, would it? But luckily it's something that is inheritable, so I could leave it to my children. Isn't that nice of me? I could always take it as cash and take it with me, right? Yeah. You heard that story, right? The guy wanted to take it with him, so the wife wrote the check and put it in the casket. Didn't hear that one?
No.
All right. So 9 million lottery jackpot. 6.8 million is paid off in 25 annual installments of that per year. I could probably do that. Or I could have 3.75 million lump sum. Tax-free lump sum, that's because the taxes are already paid on it.
That would take 2/3 of it out for taxes.
Oh yeah, at least. I would hope so.
My tax guy said that this year someone came in, they won $250,000 at the casino, and they had to pay $25,000 in for taxes.
Yep, only.
Yeah.
Yep.
I was like, dude.
Yep. It is. Yeah, gross and perverted. You better, if you're going to win at the casino, you have to keep track of your losses so you can take them off. Yeah.
Most I've won at the casino was $200, so
yeah. Well, I've never done that, so. Most I've ever lost is $20, so mostly.
Often with my dollar bills. So
I think I was 28 years old, and we're driving to California, and we were at a casino, and they have slot machines that are nickel slot machines. So I figured, hey, this is pretty cool. I'll play these nickel slot machines. And then I'm walking out, and there's this great big slot machine and a line of people lined up on it, right? And it's a slot machine that pays out $1 million. And I'm looking at these people in the line, and I see this young couple, rather dirty clothes, carrying a baby, putting in their $1. No, they didn't.
Oh.
Everyone lost that day. If you have a slot machine that pays out $1 million, it doesn't pay off but once every other year. And I'm saying, that's what's wrong. Anyway, so I never walked into another casino for 50 years after that. And then they built them in Connecticut, and instead of the scudsy things they had around Las Vegas and Nevada, the Indians put up these really cool things in Connecticut that you go into, and there's a big mall and all kinds of concessions and fancy jewelry and fine places to eat. You don't even have to go gamble, and an arena where they do sporting events. WWF comes in and does a sporting event, and so now the casinos are they're losing money on the casino side, but they're making money on the other side.
I never walk in more than I can lose.
Yeah. Well, that means you never have to walk in, right?
My money.
Yeah.
I know.
2 important observations. First, payments are made annually. Oh, the other calculation we made is my wife's 5 years older than I am. When does she start Social Security?
Today.
Does she start it at 62 and a half as soon as she can? Or does she wait until she's 66, or does she wait until she's 72? When should she start it? Well,
She should have started it now.
Didn't they change it to 60? You have to be held to get Social 65?
it's 66 for full Social Security right now. But you can get early Social Security at 62 and a half. So she took it at 62 and a half. It's all of $500 a month. It's not any big deal, but she'll have to take it for 17 years before we made the wrong decision. And by that time, we would have brought all kinds of money in. Because what happens to her Social Security when I die?
Doubled?
She doesn't get it anymore. She gets mine.
Oh.
That's right. That's right. So when your spouse dies, you get whoever has the biggest pot, you get it. So her pot's pretty small. My pot's going to be pretty big. So you start taking yours now, so that when it's time, it's time. Okay. Well, anyway.
Well,
So
now they're going to cut it. So good luck.
oh, I hope so. Yeah, they better do something. And it's so technically. That's right. You're going to be working long enough anyway.
Medicare and Medicaid.
So it'll depend on whether I get 4, 5, or 6% interest rates, which is better. So case 4% interest rate, I'm going to end up with $4 million. And if I have 4.5, I'm 4.2. And then as the interest rate changes, I'm getting less money back based on I could have gotten more money the other way. Non-mathematical reasons tend to choose the lump sum. So the lump sum's not a good deal, but people choose it anyway. That way they can spend it quicker. To finance or not to refinance a home? Well, right now, let's see. 20 years ago, I got variable rate interest rates on the loans on my retirement house in Georgia. It's down to like 2.2% right now. It's gross and perverted.
So
totally amazing.
Refinancing, aren't you just taking out another loan on your house?
Well, what you do, if you can refinance the house at a lower interest rate, and there's not a whole lot of fees attached with it, then you'll make out like a bandit in the long run. So no, you're not taking out, yes, you could refinance and take money out of the equity out of the house, and that would increase what you did. So I refinanced 7 years ago from a 30-year mortgage that's 20 years to go to a 15-year mortgage that's going to get paid off sooner. I get to pay a little more in. And that was a good deal for me. But I'm not going to refinance. I have 7 years to go. Why would I want to refinance to a 30-year mortgage with 7 years to go on the one I have?
Yeah.
That would not make any sense to me.
So I have a 30-year mortgage with a 4% interest rate.
Yeah.
Is that bad?
No, that's good. That's good. The house in Nebraska that I have is 5.5%,
Okay.
and that's perfectly okay. But it only has 7 more years to go. If it were a 30-year one, I would refinance it to a lower rate, but I'm not going to do anything with it now.
So in a couple of years, we shouldn't refinance?
Yeah, no, probably not. Unless you want to pay more and get it paid off sooner. But you can do that without refinancing. You can always pay more. You're always allowed to pay more. Yeah, that's an interesting thing. Compute the monthly payment F on your current mortgage. 30-year mortgage, 6.75%, principal's that. So there's that's your monthly payment you have to make, 11,670. And it's not really that because you still have to pay taxes, and insurance are thrown into there too. So that's probably closer to 1,800 sitting there. Compute the monthly payment F of a new mortgage at 6%. So I'm down a little bit. My interest rate went down. That guy went down, but still I'm pretty much the same. At this point, we know that if we refinance, there you go. As soon as I was reading something, I can't read it. I didn't go back, did I? I went forward. Aren't I brilliant? Oh, previous. Oh, we know that if we refinance and take out a comparable loan, the new loan picks up exactly where the old one took off, and we have some savings. So we could do that. But normally when you refinance, you take money out to do something else, put in a new kitchen or put in a new bathroom or something else, and those things happen too. Or you have some flim-flam guy going by and hosing over grandmother. You know, your basement's wet, I'm going to fix it for you. And $30,000 later, you end up not owning your house anymore. All right, so here we go. Compute the present value of a 330 month payments that at 6% interest. Okay, so if I pay that amount, then I'm going to end up paying off that amount. To refinance or not to refinance, there's going to be closing costs, and that's the real issue. So I save a little money. Am I saving a little money there? But when is the closing cost going to be paid off? 2 years from now, and I'm going to sell in a year and a half. You know, that's going to be the issue. If you're not going to stay in the house for at least another 5 years, don't even think about refinancing, because the closing costs are going to make it so it's not worthwhile. But if you're going to be there the rest of your life, then you get a little better deal, then that'd be okay. Normally the closing costs are just plowed back into the loan, so it's like you didn't see it. And anyway, so there we go, doing it again. All right, all done. Back to the last problem we have to solve, and that is 73. Okay, I didn't find 73. I found 73. Find the present value of an installment loan consisting of 25 annual payments of $3,000, and we're going to do it at 6% and 7%. 25 annual payments. Okay, so we have 25 years, and we have 3,000 per year. Okay, so we'll go. compute the present value of 33 monthly payments of that. Annual percentage rate is that. Okay, so I'm looking at page 389. Find the present value of an installment loan consisting of 25 annual payments of that. Okay, so the present value is going to be 3,000, interest rate 6, 1.06. Okay. 1 over 1.06 raised to the 25 minus 1 divided by 1 over 1.06 minus 1. Okay, that's what we're going to do. Somehow my calculator is going to do that. Or your calculator is going to do it. I think your calculator should do it, and I just should take a nap up here. What do you think? Part B, we're going to do the same thing, 75%, and we're going to do it same thing. Okay, so B is going to be 3000, 1.07, 1 over 1.07, 25 minus 1 divided by, I'm missing a parentheses here, aren't I? 1 over 1.07 minus 1. Okay. So how do we put that on our calculator and not get it wrong? I don't know. Luckily, my calculator has has 4 lines of code that I can see. So maybe with my 4 lines of code, I can get it right. 3,000 divided by 1.06 times parentheses, another parentheses, one divided by 1.06 raised to the 25 minus 1 close parentheses divided by parentheses 1 divided by 1.06 minus 1 close parentheses equals, very good. What'd you get?
First one or second one?
I got 38350.07 rounded off. You're working on the second one?
Yeah.
Okay.
I can't figure out how to work my calculator.
That is a definite problem. Okay, so what I would do, does your calculator, how dumb is your calculator? Oh, well that calculator, you just
It's
put it
not
in.
dumb at all.
It's not, I
No.
mean, that's not a dumb calculator at all, you just put it in.
Mine.
Yeah.
My calculator is crap.
Yeah, it's a crap calculator, yeah.
I took college algebra, so you'd think I would know how to work it.
How to work a calculator? Yes, I agree.
Next one I got like 34,960.75.
Yeah, probably. That'd probably be close. You got 34960.75.
Yep.
All right. So smart calculators, no excuse. Dumb calculators, it might be a little more of a challenge to, because your calculator, you just put it in just as you see it.
No, but I can't find my fraction button.
It can't find your fraction button. You don't have to use your fraction button. Just use the divide sign.
Yeah.
Yeah. Just make sure you have enough parentheses. So put an extra set of parentheses there. So you could go 3,000 divide key 10.07 times key parentheses 1 divided by 1.07 parentheses raised to the 25 minus 1 parentheses divide by parentheses 1 divided by 1.07 minus 1 close parentheses, and assuming
You need another parentheses at the.
I need another parentheses at the end.
Yeah.
Okay.
Cover up the first one.
Okay. So you could just put that directly in your calculator.
I could probably do it on mine, but it's not long enough. So I just
Yeah, it's not long enough to see it all. Yeah.
Surprisingly, my calculator's got a graphing calculator,
Mhm.
log symbols. Would be enough.
Totally amazing.
I'm surprised.
Okay, with that, we'll pass out
Think
the
about,
quizzes.
You can do it
for
now.
next time.
I think that's the
think about.
I gotta decide who's Brittany.
Thank you.
So when I was younger, I could remember names. There's only 4 of them, so. Well, luckily you guys sit in the same seat. Scott would have said something different.
Yeah.
Did you even take that? Oh, no, you took this one home.
Yeah.
In the break. Okay, so I have to bring that one. Okay, excellent. So I'll pass out the quiz for today. Pass some finished for today. Yeah, today we only have $1 sheet, but that means there's no paper. You know. No papers. Okay, excellent. I don't think I put this particular thing on the web yet. So that's because I knew you were all going to be there. Okay, ready? I don't have the last one figured out yet, but I figured my entire life I'll probably never get it figured out. Okay. Well, anybody got an answer to the first one?
B.
Anybody not want B? B is correct. So you get confused, you might multiply by 0.75, but that's the discount, so you have to multiply by a quarter. And problem number 2. We find that there's $3,105 in interest. I divide by 12, I get some yearly interest. I divide that by the principal, 4,500, and I end up with 5.75%, which is E. Okay, anybody for 3?
I guess D.
D. Let me check.
I think so. Pretty sure it's wrong. D is in dog.
Yeah, B is in Bravo. Yeah. That's what you're trying to say. You're mumbling over there, but you're really trying to say B is in Bravo. So we have 365 days a year. You divide it into 7.75, and you come up with 0.02.
I just jumped the gun.
And we only have 3 significant digits, so we just keep 3 significant digits. Okay, next one. Well, if I'm going to donate $10 a week, and I donate $10 times 52 weeks times 25 years, the cash alone is $13,000. That being the case, all the answers there are wrong.
I'm gonna say.
I mean, by a huge amount. So once you get by the idea that all the answers there are wrong, and you plug it in your calculator, you come up with it's worth $30,175. But that's not very nice. Not even having answered half the value of the money with no interest. I mean, give me a break, guys, right? Number 5. A. Yeah, 75 by 2.2 would make it A. I can do that in my head. Yeah, pretty much. And number 6, I ran out of time, so I didn't solve it. But
What was the answer to 4?
4?
Nothing.
30,175.
Okay, that's why I got confused.
Yeah, there is no answer there even close, because $10 a week times 52 weeks times 25 years is $13,000 in cash by itself. So some graduate student made up the answer key, and they really blew that one bad. How can you possibly be that far off? Okay. Where are we? Deal 1 is $486. Deal 2 is $511. That makes deal 1 the best deal. So take the cash and deal with the 5.5% financing. That'd be perfectly okay. Okay, put your name and your grade on top of your quiz and pass it in. Next week we'll start with a test. We'll do it closed book. I'll grade it. We'll pass it back. We'll do it open book. We'll grade it again. Once you pass it back in the second time, there's no reason to hang out unless you want to stand in back of me and watch me grade it. That'd be okay. Thank you very much. And see you Thursday? Yep, see you Thursday.